Hello everybody and welcome to my channel. In this video I'll show you how to compile a simple C program, hello world program actually. I know it's nothing exciting, but trust me, stick to the end of the video, you'll learn something new. Okay, so to start off I'm gonna be using WSL, which is like a virtual machine, allows us to run Linux in it. First of all, we need a compiler for C. The most popular one is called GCC, so I'm gonna install that really quickly. And just like that, I installed it. The command will vary if you use a different distro. This works on Debian-based distributions. If you're on Fedora, probably do like, I don't know, then install GCC or something. But this is for Ubuntu. Okay, so I'm gonna be using Vim as my editor, by the way. It's pretty cool. I'm gonna call the file, the source code, the program I'm gonna be making example C, and we get greeted with a nice empty file. So what makes a C program for starters? The main function. It's the main function in any C program. It's the function that gets called when the program starts. It's the most important function in the program because it's what initially gets called. And every program needs a main function. The only exception, I guess, is if you're making something that's supposed to be included, then you don't need a main function. But yeah, that's a topic for another video. Okay, so let's just say printf hello world, and let me return 0. Okay. Okay, so let me explain every line in here. So include studio.h, which is short for header. It's basically including a lot of the standard input-output functions. For instance, printf. This function is defined here. Okay, so this is needed if you're going to use printf or other common built-in standard functions. You're going to need to include it. Okay, and the next line is int main. Basically, we're defining a function here, and we're saying that it returns an integer. And then the curly brackets are simply like, this is the block of code related to this function. So int main is required to be in every C program. It's the first function that gets called. Very important. But our program is really simple. We just printf. We call the function printf, and we pass in an argument. That's hello world. It's a string. A string is denoted by the double quotes at the start and at the end. So let me actually add a new line at the end. So 1 second. Okay, a new line here. So it says hello world and then a new line. And then return 0 basically, because remember, main returns an integer. So return 0 basically is saying to whoever called the program, I executed successfully. If we return anything other than 0, that means something came up, some invalid option you provided or something like that. So 0 means everything executed successfully. If we say, like, if this program was checking for a password or something, you might want to return 1 on the wrong password. Okay, so let's exit and compile this. Out hello world. So it works. We can actually view the status, the return status. As you can see, 0, just like how we defined it here. Now let's say we change 0 to anything like 69, for instance. And then let's compile this, run it, and then 69. You see that? That's great. So if I was running this program, and I wanted to know if it ran successfully or not, I could check this, the return status, and say if 69, then do something, you know? Okay, this is cool and all, but let's say we want to know how this program works, and we didn't have, let's say, the source code. We didn't have this. All we had is the program itself, the program binary, I mean. So all we had is this. How would we figure out how this program actually works under the hood without the source code? So the way to do this is to reverse engineer it, basically. So when we created this program, we engineered it. We're gonna do the reverse of that. And there's a lot of tools out there that allow you to do this. We're gonna be using a tool called Ghidra. This one you can download. If you're on Windows, simply install this Java GTK. I already installed it, so I don't need to install it. But yeah, you just download this, install it, and then download Ghidra from the release page. Download this. I already downloaded, so I won't download it. And yeah, let's get started. After you downloaded it, I downloaded here, here. We're simply gonna double click that bat file to start Ghidra. Okay, close this. Okay, so this is Ghidra project window. First we're gonna create a new project, non-shared. I'm gonna call this. Let's create a new folder. Let's call it. Actually, let's just select it without renaming it. Let's call this project name RE Hello World. Okay, so there's a project. Now we need the binary. So I'm gonna copy the binary into my desktop, like that. Yeah, and then I'm simply going to drag and drop it here. As you can see, it tells us, it's telling us basically choose what language this binary is written in and stuff. It's been compiled with GCC, 64-bit, low Indian. You know, that sounds correct. So I'm gonna click OK. And it gives us even more information now. Let me just minimize this. You can see this is a date it's been compiled on. The compiler, you know, a lot of stuff, even the extra stuff like our operating system that was compiled on. So let's click OK, and then double click on it. This will bring up the code browser, and it's going to ask you to analyze it. So you're going to press yes. Okay, so simply leave these alone, honestly, if you don't know what you're messing with. I'm just going to leave them as is and click analyze. So this is our binary. This is the assembly code, and on the left here we can see the simple tree, because remember we compiled this, we didn't strip any of the simples, so it's going to make it easy for us. So if I expand this functions folder, we can see a lot of the functions in the program. But wait a minute, it's way too many functions. This in our program we only had one function, main, but of course when you compile it, a lot of functions get bundled in and stuff, so those are that. So let's click on main function. This is the one we wrote, and we can see here the decompiled code. It's basically not real code, it's bestow code. It's just meant to make you understand how it works, but not actually like copy paste it and expect it to work flawlessly. So let me just, so as you can see here, it decompiled it pretty good, but we need to actually, I mean, see here, it didn't get the functions type correctly. It says undefined, and since we already know that, you know, every main function returns an integer, we can safely edit the function signature. Simply say int. One more thing, we should, since this binary was compiled on Linux, we should set the calling convention to default, and then click OK. Now it's more correct. So as you can see, this is like one-to-one match to our code, well, almost at least. One of the major differences, I guess you could call it, is the fact that here the function is called puts. Puts instead of printf. Here we use printf. Here is called puts. So what's going on here? Basically, the compiler has a lot of optimizations. It saw we were using printf, but we didn't actually format any string, right? Printf supports a lot of complex string formatting and stuff that we didn't use. We simply had a simple string. So the compiler saw that and said, oh, okay, I'm gonna replace this with puts because it makes more sense and can be more performant, increase the performance. So there's that, and as you can see, the return code here in Ghidra, it's displayed as hex. If we right click on it, we can see the decimal is 69. One thing I said earlier, that the main function is the most important function. That's actually not correct. The most important function is the start function. This is the real function that gets called on every program before main. You know, start actually is the one that calls main. So yeah, this is Ghidra, and the way we just edited function signature, I mean, this program is really simple, so this was really easy to quote-unquote reverse engineer. But on bigger programs, this can be tedious, you know, to individually go through each function, understand how it works, retype the types and convention and this and that. It gets really tiresome. Let's actually use puts instead of hello world, this, you know, in our program, and see how this works. Okay, puts hi. Notice how we didn't even put a new line here, because puts automatically puts a new line. Let's compile this really quickly, and it says hi and a new line. So let's try printf hello world, but without a new line. As you can see, without a new line, it gets garbled up in our output in terminal. But now let's actually let me delete this one, and let's copy the new binary. Okay, copy it back to Ghidra. Okay, double click it, analyze, main, and right now we see the compiler didn't replace printf with puts. Why? Because puts a new line character at the end of the string, and that's not what we wrote, right? So the compiler decides not to replace printf with puts because it's not what we wrote. You know, it'd be funny if we didn't type a new line character and it gave us a new line on you know, on printf instead of puts. So this is pretty much it. Thank you for watching, and subscribe and like.